In this video, we're going to go over the Unit 4 review for pre-calc. Number 1 asks us to expand these polynomials and write our answers in simplified form. So you can multiply polynomials together using the box or by distributing. So I'm just going to do both for this first one. So I'm first going to do it by distributing. Some people call this FOIL method, but 2x times 3x is 6x squared. Then I'm going to distribute the 2x to the 4. So that's going to give me 8x. Then I'm going to distribute the negative 5 to both. So negative 5 times 3x is negative 15x. And then negative 5 times 4 is negative 20. Then we'll just go ahead and combine our like terms here. So we'll put these x terms together. So we have 6x squared. 8x minus 15x is negative 7x. And then we have that minus 20. So that would be our final answer there. If you're doing this in the box, then you would just make a 2 by 2 box since we're multiplying two binomials together. And you would put the binomials on either side. It doesn't matter which side you put them. So I'm going to put 2x minus 5 here. And then I'm going to put 3x plus 4 here. Then we just multiply the columns by the rows and put it where it intersects. So 2x times 3x is 6x squared. 2x times 4 is 8x. Negative 5 times 3x is negative 15x. And negative 5 times 4 is negative 20. So you'll see we get these same 4 terms. Then this one and this one again are like terms. So when we take it out, we'll have 6x squared, negative 15x, and 8x is negative 7x, and then that negative 20. So you end up with the same answer, just depends on how you like to organize your information. All right, then in part B, now we've got x plus 5 times x plus 5. So remember when you do x plus 5 squared, don't just bring this squared in. Okay, this is x plus 5 squared is really doing x plus 5 times x plus 5. So we've got this 3, and then we're going to multiply it by when we multiply this out. So this is going to be x squared. Then we're going to get a 5x and a 5x as our middle term. So that's going to be plus 10x. And then we're going to get 5 times 5, which is 25. So you have 3 times that polynomial. Then we will distribute in this negative 4. So we're going to distribute negative 4 to x, which is negative 4x, and then negative 4 to 5, which is negative 20. And you still have this plus 6 here. So then we'll distribute this 3 into each of these. So we'll get 3x squared plus 30x plus 75. And then we still have the minus 4x, minus 20, and plus 6. So now that we've expanded everything, now we can start combining like terms. So 3x squared is our only x squared term. Then we have 30x and negative 4x. So 30x minus 4x is a positive 26x. Then we have a positive 7 with a negative 20. That's going to be negative 13. And then plus 6 more. So negative 13 plus 6 is negative 7. So then this would be our final expanded answer. Number 2 asks us to factor these different polynomials. So often people will factor trinomials with an a value here in the box. So let me just draw out a box here. And then we'll cut this to a 2 by 2, and then we're going to put a circle in the middle for our middle like terms. So then you put your original polynomial here down the corners. So we'll put 6x squared here, negative 37x, and then positive 6. So then you're going to want to multiply these terms, the 6x squared and the 6. So that's 36x squared. And then you find the factors of this number that add to negative 37. So it needs to multiply to positive 36 and add to negative 37. So that's going to be negative 36x and negative 1x. So you can put these in these corners however you want. I'm going to put the negative 1x on top here and the negative 36x down here. Then you take out a common factor. So what's in common between these top two terms? So 6 and negative 1 have nothing in common, but they do both have an x. And then you just fill it up. So what times x will give us 6x squared? So that's 6x. X times negative 1 will give us this negative 1x. And then 6x times negative 6 will give us negative 36. And then I always just check this last box here too. So negative 6 times negative 1 is positive 6. So then these purple are your factors. So we'll just put parentheses around those. So 6x minus 1 from the top and x minus 6 from the side. So here's our factored version. B, when we look at this, hopefully we see that we have a common factor here of 3x plus 5. So we'll be able to just take this out since it's in common. And what we're left with when we take that out, so when we take that out of our first term, we're left with this 17x. And when we take that out of our second term, we're left with this minus 2. And then that's fully factored because each of those are just linear factors. Part C, you hopefully see that there's a common factor here of an x. So first thing that you'll want to do is factor an x out. So we'll have 4x squared minus 25. So now you want to just look at this inner part here of 4x squared minus 25 and realize that both of those are square numbers. So we have a difference of squares. So this will factor to the square root of each of those. So the square root of 4x squared is just 2x, and the square root of 25 is 5. So we'll have these two numbers here twice. We'll have a plus in one factor and a minus in the other. So this 4x cubed minus 25x factors to this. For D, now we have more than a trinomial. Okay, so this has 4 terms, and there are no like terms in any of them. So this one we're going to factor by grouping. So we're going to look at just the first 2 terms here. So what do these 2 terms have in common? So the 4 and the 7, nothing. Okay, but they do each have an x squared. So we're going to write that out. And when we take an x squared out, so 4x cubed divided by 1x squared is just 4x. 7x squared divided by x squared is just 7. So then we're going to go to this next part, and we're going to see what's in common between these. So what's in common here is these are both divisible by 9. So we'll have a plus 9 that we take out. So 36x divided by 9 is 4x, and 63 divided by 9 is positive 7. So now when we look here, it's very similar to part C, where we had that common binomial factor. So now we see that we have 4x plus 7 in each of these. So 4x plus 7 is what we'll take out. And when we take that out, what we're left with in this one, once we get rid of this, is just the x squared. And in this one, once we get rid of it, is the plus 9. And then neither of these are factorable. So this x squared plus 9 is kind of like this one, except for this one had a minus. So this is a difference of squares. We can't factor a sum of squares. So this is already factored as far as it can go. Number 3 wants us to solve each of these equations. So we're going to do that by getting rid of the denominator by multiplying by the least common denominator. So when we look here, this has a denominator of a 1, this has an x plus 2, and this has an x plus 2. So we're going to multiply both sides by x plus 2, which is kind of the only denominator here. So we'll just multiply this into all the terms. So we'll do that x times x plus 2. Okay, then we'll take this middle term, okay, which is x plus 3 over x plus 2. And we're going to multiply that by the x plus 2. So we're distributing this in. So this will be multiplied by x plus 2. And then we have the 7 over x plus 2. And we will multiply the x plus 2 into that as well. So you can see that I multiplied that into the original, so the original in black, and then I just multiplied in that x plus 2. So now what we're left with, we can start crossing out common factors here. So there's nothing in common here. Here we have an x plus 2 on top and bottom, so that'll divide out to 1. And here we also have an x plus 2 on top and bottom, so that'll divide out to 1. So now what we're left with is x times x plus 2 plus just this x plus 3, so I don't need parentheses anymore, and then equals just this 7. So now we'll want to expand this. So we'll distribute this x in, and we're going to do this so that we can see if there's any like terms to combine. So x times x is x squared, x times 2 is 2x, and then after we've combined like terms, we're going to work to solve. So now we see that we have this 2x and this x. So we'll do x squared, 2x plus x is 3x, and then plus 3 equals 7. So now you have a quadratic. So then we need to get everything to one side so that it's set equal to 0 so we can factor and solve. So we'll just subtract 7. So you get x squared plus 3x minus 4 equals 0. And now we can factor this quadratic. Since this a value is only a 1, okay, you can just find the factors of -4 that add to 3. So that's +4 and -1. So that's 4 times -1 is -4. 4x plus -1x is that 3x. And then we just set these equal to 0 and solve. So subtract 4 from both sides. And then here add 1 to both sides. So our two answers are -4 and 1. And then we always just want to make sure whether they will make our denominator 0. So I'm just going to write x equals, what was it, -4 and 1. And now neither of those make the denominator 0, so both of these are solutions. In this next one, we want to make sure that we factor the denominator first so that we can see the factors. So this is a difference of squares, so that's going to factor to x plus 2, x minus 2, in which case now we'll multiply by both x minus 2 and x plus 2 so that we can get rid of that denominator. Okay, so we're going to have to multiply by both of them. So I'm just going to write them over here since I don't really have room on that side. So when we multiply these in, we're going to have the 1, and then we're going to multiply that times this x plus 2, x minus 2. So I'm just going to duplicate this. And then we have plus 2 over x minus 2, and we're going to multiply by this again. Okay, and then let me move this over. Oops. All right, so then equals, and then we're going to have this 3 over x plus 2, x minus 2, and we're going to multiply by this x plus 2 minus 2 again. So I'm just going to set it up there. All right, so then we can start canceling out our common factors. So there's nothing that cancels out here. the x minus 2's cancel, and over here, both of them cancel. So now we're going to start expanding this. Okay, so we have this x plus 2 times x minus 2. And then we have the 2 times x plus 2. And then we have equals 3. So this will multiply out to x squared minus 4. If we do x times x is x squared, negative 2x and 2x will cancel, and then the final term will be negative 4. And then here we'll distribute the 2, so we get plus 2x plus 4, and then equals 3. So this negative 4 and positive 4 will equal 0. So we'll have x squared plus 2x. And then I'm going to subtract this 3 over as well, since I have a quadratic, and I'm going to want to factor. So I want everything on one side. So now we're going to take and factor this. So we want the factors of negative 3 that add to positive 2. So we're going to want plus 3 and minus 1. So then we'll set each of these equal to 0. So here we get x equals negative 3 and x equals 1. So then we'll go back up to our original problem, and we got x equals negative 3 and 1. And neither of those make the denominator 0, because a 2 and a negative 2 would do that. And so those are both solutions. Number 5, very similar thing. This one's just already factored for us. So let's go ahead and multiply by our least common denominator. So we see that we need an x plus 7. And then we also see an x minus 7. So we're going to multiply this into all of these. So this time I'm not going to write them out each time. I'm just going to write out what doesn't cancel. So here when we multiply this in, an x plus 7 will cancel. So we'll be left with 1 times just the x minus 7. And then plus, so when we multiply this into the 7 over x minus 7, the x minus 7 will cancel. So the only factor that will still be there is x plus 7. Okay, then equals x. And when we multiply this in, again, the x minus 7 will cancel. So we'll just have the x plus 7 there. So now let's expand these. So we just have x minus 7 here. We're going to distribute the 7 in. So we'll get 7x plus 49. And then here we'll distribute the x in. So we'll get x squared plus 7x. So you can combine your like terms over here first if you would like to. So x and 7x is 8x. Negative 7 and positive 49 is positive 42. That equals x squared plus 7x. So now we have x and x squared. So we're going to want everything on the same side. I don't like my x squared term to be negative. So I'm going to bring this 8x over here. And I'm also going to bring the 42 over. So then this will be 0 and 0. So we get 0 equals x squared. 7x minus 8x is negative 1x. And then we have the negative 42. So now we're going to want to factor this. So we've got an a value of 1. So we just want the factors of negative 42 that add to negative 1. So that's going to be negative 7 and positive 6. So when we set these equal to 0, we'll add 7 to both sides and get 7. Here we'll subtract 6 from both sides and get negative 6. So then let's go back up here and then let's check these values. So we got x equals 7 and negative 6. So if we plug 7 in here, we're going to get 0 in the denominator, and we are not allowed to have division by 0. So this is called an extraneous solution. You just cross it off. So the only solution to this one is x equals negative 6. Number 5, let's go ahead and start by factoring again because we see this denominator is multiplied out. So we want factors of positive 6 that add to positive 5. So we need both positive factors. So x plus 2, x plus 3. which is good because that's these two denominators. So then we're just going to multiply everything by those two terms. So x plus 2 and x plus 3. And so again, I'm just going to write out what doesn't cancel out. So when we do this times this, we're going to have x times, and then the x plus 2 will cancel. So we'll just have the x plus 3. Then here we'll have plus 2 times, and the x plus 3 will cancel, so we'll just have this x plus 2. And then equals just 3x plus 7, because when we multiply this in to that one, both of these will cancel. So we'll just be left with the 3x plus 7. So then we'll expand this. So we get x squared plus 3x. And then we get plus 2x plus 4 equals 3x plus 7. Combine your like terms. So we get x squared plus 5x plus 4 equals 3x. We again see that we've got an x squared, so we want to get everything to one side. So I'm going to subtract the 3x over here, and I'm going to subtract the 7. So then we'll end up with x squared plus 2x minus 3 equals 0. So now we'll want to factor this, and we have an a value of 1 again. So we'll just find the factors of negative 3 that add to positive 2. So that's going to be plus 3 and minus 1. So the answers that we'll get when we subtract 3 is going to be x equals negative 3, and we'll add 1 here to get 1. So the two values we need to check are negative 3 and 1 into our original denominators. And we know that when we plug negative 3 into here, that will give us 0. So we're going to cross that out. And our only solution, so this one was extraneous, so our only solution is x equals 1. Number 7, we're going to find the oblique asymptote. So what we do for that is we divide. And so I'm just going to divide it in the box. I'm just going to draw out a box that has 2 rows since I'm dividing by a binomial. So I'm going to write that binomial off to the side. And then I'm going to put this first term 2x squared here. And that will help me figure out this term, because this times this needs to equal 2x squared. So x times 2x equals 2x squared. So then I can multiply these two and fill in this as 4x. Then you know that this term and this term are like terms, and they need to equal the x term here. So 4x plus negative 3x would give us 1x. So then that will help us figure out this top one. X times negative 3 gives us that 3x. Now the rest of this is just going to give us a remainder, and we don't care about the remainder because this is our end behavior or oblique asymptote. So just y equals 2x minus 3. And remember, it's the equation of a line, so you got to make sure that you have y equals whatever you get up there. All right, then let's graph 2 problems here. So first thing you should do is make sure that you factor this, okay? So that we can see if there's any common factors top to bottom. So this x squared minus 4 factors to x minus 2, x plus 2. So that's our factored version. I guess that's what this problem asks, so I can write it there. All right, so there it is written in factored form. So now when we go to find the horizontal asymptotes, that's our end behavior asymptote, okay? Horizontal or slant asymptote. When your degree on top is smaller than the bottom, this means that your horizontal asymptote is automatically y equals 0. Okay, because the degree on top was 1 and the degree on bottom was 2. If it's bigger on the bottom, it's automatically 0. So then when we go to find the vertical asymptote is where you get division by 0. So these are any factors that are unique to the denominator, we set equal to 0. And that will give us our vertical asymptotes. So we'll do x minus 2 equals 0, add 2 to both sides, so we get x equals 2 as an asymptote. And then x plus 2 equals 0, so subtract 2 from both sides, and you get x equals negative 2 as a vertical asymptote as well. So this one has 2 vertical asymptotes, okay, at negative 2. And remember to do dotted lines for these because they're not actually part of your graph. They're just boundary lines to help us. And then that end behavior asymptote was y equals 0. So that's here. Then it wants us to determine any x-intercepts. So remember that the x-intercept is where your function equals 0. So it's going to be where this r of x equals 0, which means that the top will be 0. Okay, because anything, 0 divided by any number is 0. So as long as this top is 0, the whole function will be 0. So we'll set 2x equal to 0, divide by 2, and we get x equals 0. So this is actually an ordered pair, so we shouldn't really have x equals here, but it'll just be 0, 0 is your x-intercept. So that's going to be right there at the origin. Your y-intercept is when your x equals 0. So we just plug 0 in here. Now 0, 0, if that's your x-intercept, it's also your y-intercept. But if that wasn't the case, you would just plug 0 into this whole thing. So you would do 2 times 0 for the top, and you would do 0 squared minus 4 on the bottom. So 2 times 0 is 0. 0 minus 4 is negative 4. 0 divided by negative 4 is 0. So that's what would get you that y-intercept of 0, 0 as well. Then does this function contain a whole? That's only if there are shared factors on top and bottom. So this one does not have a whole because there aren't any shared or common factors between the top and bottom. So no whole. And then this one just wants us then to sketch a graph. And so you could just plug this into your calculator to see where these branches go. Just make sure you put parentheses around the top and bottom. And I actually wouldn't put in the factored form if you're typing this in your calculator. If you're typing it in your calculator, I would go y equals parenthesis 2x parenthesis divided by parenthesis x squared minus 4. And then you'll see that your branches are down here. And then here. And then here. And you could just plug in a point, like you could plug in negative 4 and see that it gave you a negative number. You could plug in negative 1, see that it gave you a positive, plug in 1, see it gave you a negative, and plug in 4 and see it gave you a positive to figure out where those branches go as well. All right, then the last one is another graphing one. So let's factor this again. So let's write r of x in factored form. So the top is already good, so x minus 3. Then the bottom has an a value of 1 again, so we can just find the factors of negative 15 that add to positive 2. So that's going to, I probably need a little bit more space here, so let me write these better. So that's going to be x plus 5 and x minus 3. So that's going to multiply to negative 15 and add to positive 2. So in this case, let's jump to the whole first because we see that there's a shared factor on top and bottom. So there is a whole here, and it's happening when x equals positive 3 because that's what makes this factor 0. So then when you go to figure out the whole, you can just kind of think of these as canceling out. So then there's a 1 up here. So when you go to figure out the coordinates of the whole, you plug the 3 in, but just to the 1 over x plus 5. So then we'll go 1 over x, which was 3, plus 5. So that's 1/8. So the y value is 1/8. So 3/1/8 is a whole. So there's going to be a whole right about there. And I can probably make this skinnier so we can see that I actually did a whole there. Okay, so there's your whole. So now when you go to find the horizontal asymptote, okay, so horizontal asymptote is looking at the degree of the top over the degree of the bottom. So the degree on top is 1, the degree on the bottom is 2. So top is smaller than bottom, so the horizontal asymptote is automatically y equals 0. So we'll go ahead and plot that on here. And then vertical asymptote is where the denominator is 0, and it's where only the unique factor, so not this x minus 3 that made the whole, so we'll do the x plus 5 equals 0, so x equals -5 for that vertical asymptote. So we'll just go over here to -5, so this is -2, 4, halfway between is -5. Determine the x-intercepts. So again, this is what will make the top 0 so that the whole function is 0, because an x-intercept has a y value of 0. So then we'll do set the top equal to 0. So then we would just, well, and actually we can't do that because that's the whole. Okay, I forgot. We should be looking at this one. Okay, and now there's no other factor up there. So the unique factor up top is just a 1, and that will never equal 0. So there is not going to be an x-intercept here. So no x-intercept. So don't forget, plug it back into this one where you canceled out the common factor, not to the original. And then y-intercept is where x equals 0. So we'll just plug 0 in to this function. And when we plug 0 in, we get 1 over 0 plus 5. So that's 1/5. So your y-intercept is 0, 1/5. So that's going to cross down here. And so now you can sketch your graph. And now we know that this graph is in this section of it. So we'll just draw our branches in. It's going to go here. It's going to hit this hole, okay, but not go through it. So you're going to have a hole right there. And then it's always in the opposite quadrant. So then it's also going to be here. And then let's actually talk about the domain in this one, just to make sure that we understand the domain. So the domain here is going to be all of the values except for, whoops, not that, all of the values except for this vertical asymptote. So everything is covered from -infinity until infinity except for this x value, okay, of -5. So if we were going to write this domain, okay, in interval notation, we would say -infinity up until -5. And then it starts again at -5 and goes until infinity. So soft brackets on this -5 because it doesn't include it. And then let's go back and look at the domain here. So for here, we're good at -infinity up until this value, which is -2. And then we're good from here to here until we get to this x value, which is 2. And then we're good to infinity. So for this one, we would have -infinity up until -2. Then we would be good between -2 and 2. And then we would be good from 2 to infinity. Soft brackets on all of that, since we can't include the -2 or the 2. And that's how you would do the domains.